Hello, astronomy lovers. I'm Astronomy Universe, where we share cosmic science knowledge in a sophisticated, insightful, and accessible way. Today, let's embark on a journey through the solar system, a vast celestial family with the Sun reigning at its center and 8 planets, along with countless asteroids, comets, and other minor bodies, all orbiting under its immense gravitational pull. It all began with a massive molecular cloud collapsing about 4.6 billion years ago, and ever since, this tiny cosmic neighborhood has been our shared home, the Sun, a plasma flame amid infinite space. When we look up at the blue sky by day, we all feel warmth seeping through our skin. That warmth is the light and energy radiating from the Sun, the heart of the solar system, where every motion and orbit originates from its unrivaled gravity and intense heat. This gigantic sphere of plasma, with an equatorial radius of about 695,700 km, 109 times Earth's diameter, contains some 99.86% of the system's total mass. Deep in its core, temperatures reach nearly 15 million degrees Celsius, driving nuclear fusion that converts hydrogen into helium and releases energy as photons and gamma rays. The light produced in the core takes tens of thousands of years to make its way to the photosphere, then embarks on an 8-minute, 20-second sprint to reach Earth. The Sun's role extends far beyond merely providing heat and light. Its immense gravitational pull with surface gravity around 274 m, S100 acts like cosmic glue, binding the 8 planets, asteroids, comets, and countless stray meteoroids into a miraculous ballet of equilibrium. Without this star, Earth would drift into the void, freeze solid, and life as we know it could never flourish. Across the solar surface, we observe dark spots, sunspots areas, where the plasma is cooler by 1,500 degrees Celsius than their surroundings, yet still about 1,000 times hotter than Earth's surface. These regions of intense magnetic activity spawn X-ray flares and space weather events that can disrupt satellites, power grids, and communications. The Sun is also the prime witness to our solar system's birth. Some 4.6 billion years ago, a vast cloud of dust and molecular gas collapsed under its own gravity. As plasma formed and heated the core, the planets came into being. Every sunrise and sunset on Earth reminds us of this star's grandeur, as it faithfully ignites our tiny cosmic neighborhood day after day. Mercury, the swift messenger. Mercury is the smallest planet and the closest to the Sun, lying just 57.9 million kilometers from the solar center, with an orbital period of only 88 Earth days. It is the sprinter of our solar system. Its rugged surface is peppered with impact, craters the scars of billions of years of bombardment by comets and asteroids, making it look more like a giant moon than a planet. Mercury's atmosphere is virtually non-existent. Surface pressure is only about 1/100 that of Earth. As a result, daytime temperatures can soar up to 430 degrees Celsius, then plunge to 180 degrees Celsius at night, creating a thermal swing of over 600 degrees, the largest of any planet. Its name comes from the Roman god Mercury, the fleet-footed messenger of the gods. In ancient Eastern tradition, it was called Thui Vi Tin, associated with the water element in the 5 phases, because its orbit lies inside Earth's and it appears and disappears in the twilight sky. In terms of exploration, NASA's Mariner 10, 1974, 1975, was the first probe to fly by, capturing the earliest images. In the early 2000s, Messenger orbited Mercury for nearly 6 years, mapping its terrain, studying its tenuous exosphere, and analyzing its surface chemistry. Today, the joint ESA-JAXA mission Bepi-Colombo is en route, promising to reveal new insights into Mercury's ultra-dense iron core and magnetic history. Venus, the sister planet beneath an oppressive veil. Venus, Earth's mysterious sister, is the second planet from the Sun at about 108 million kilometers away. In size, its radius is only some 650 kilometers smaller than Earth's, yet its dense atmosphere, composed of roughly 96% carbon dioxide, turned it into a colossal greenhouse. Surface pressure soars to nearly 92 bar, 92 times that at Earth's surface, enough to crush any probe not specially reinforced. Average surface temperatures hover around 465 degrees hotter than molten lead, remain virtually unchanged at night, thanks to thick sulfuric acid clouds that trap and reflect heat back down. Venus completes one orbit of the Sun in 224.7 Earth days, but its slow, retrograde rotation means a single Venusian day, one full spin on its axis, lasts 243 Earth days, and it spins in the opposite direction of most other planets. Since the 1960s, the Soviet Venera missions have pierced Venus's cloud layer, sending back hazy black and white photographs of its scorching surface. NASA's Magellan spacecraft later used radar to map its topography, unveiling vast volcanic plains and winding canyon-like valleys. More recently, Japan's Akatsuki orbiter has been studying the dynamics of those towering clouds and even detecting acoustic waves within the atmosphere. Perhaps most intriguingly, traces of phosphine, pH3, a compound on Earth associated almost exclusively with microbial life, have been reported high in Venus's cloud decks. If these phosphine detections are confirmed, they could represent our first hint of bacteria surviving amid the most extreme conditions in the solar system. Earth, the only known home of life. Earth is the third planet from the Sun, orbiting at an average distance of 1 astronomical unit, 150 million kilometers. It spins on its axis once every 23 hours and 56 minutes, and completes a circuit around the Sun in 365.25 days. Its 23.4 degrees axial tilt gives rise to 4 distinct seasons. About 71% of Earth's surface is covered by water from the deepest ocean trenches to the vast expanse of seas and lakes, while the remainder is land, sculpted into towering mountains, winding valleys, scorching deserts, and lush forests. The atmosphere that cloaks the planet is composed of roughly 78% nitrogen and 21% oxygen, with just the right balance of water vapor and greenhouse gases to regulate temperature, shield life from ultraviolet radiation, and sustain the global water cycle. At the heart of our planet lies life itself, from the first microbial cells that appeared some 3.5 billion years ago to the millions of plant and animal species that now weave a complex web of ecosystems. The carbon, nitrogen, and water cycles are deeply entwined rainforests, like the Amazon, help stabilize climate, while coral reefs on the ocean floor foster astonishing biodiversity. Yet today, climate change, pollution, and overexploitation are pushing Earth toward a critical threshold. The choices we make now will determine the future of this blue oasis, the only world we know that teems with life. Mars, the mysterious red planet. Mars, the fourth planet from the Sun, orbits at an average distance of about 228 million kilometers. With a year lasting 687 Earth days and a day, one full rotation of 24 hours 39 minutes, the red planet's spin is strikingly similar to Earth's. Yet its tenuous atmosphere, just around 1% of Earth's surface pressure and composed mostly of CO2, creates an exceptionally harsh environment. Its fiery red hue comes from iron oxide dust that blankets the surface. You can easily spot Valles Marineris, a canyon system over 0 kilometers long, Olympus Mons, a colossal volcano rising 21 kilometers high, the tallest mountain in the solar system, and 2 polar ice caps made of water ice and frozen CO2. Occasionally, planet-wide dust storms envelop Mars, turning its sky from pale pink to a brooding gray. NASA's Viking landers, the Spirit and Opportunity rovers, Curiosity, and most recently Perseverance have all surveyed Mars's surface. They've uncovered ancient dried-up river channels, salt deposits, and water-bearing mineral sloughs that Mars once harbored a wetter environment potentially capable of supporting microbial life. In the not-too-distant future, crude missions and even proposals to terraform the planet continue to fuel humanity's fascination with the red planet. Jupiter, the mighty gas giant emperor. Jupiter stands proudly as the 5th planet from the Sun, orbiting at an average distance of about 778 million kilometers. With a mass some 2.5 times that of all the other planets combined, it rules the solar system as its undisputed boss. Composed predominantly of hydrogen, is approximately equal to 90%, and helium is approximately equal to 10%, Jupiter lacks a solid surface. Instead, pressure and temperature rise steadily beneath its upper cloud layers, where temperatures can reach up to 24,000 degrees Celsius, compressing hydrogen into an exotic, electrically conductive, metallic state that powers a magnetic field of staggering strength. At the center of every telescope's gaze is the Great Red Spotostorm, raging for over 350 years, large enough to engulf 3 Earths. Rotating counterclockwise, it completes one circuit in roughly 6 Earth days, its vivid crimson swirl set against bands of white, yellow, and brown clouds. Despite its immense size, Jupiter spins on its axis in just 9 hours 55 minutes, flattening noticeably at the equator. Its equatorial radius exceeds its polar radius by about 600 kilometers. Yet it takes a full 11.86 Earth years to complete one orbit of the Sun, experiencing a decade-long season under sunlight over 25 times weaker than what we receive on Earth. Jupiter's own family includes more than 79 moons, led by the Galilean Quartet. Io, ablaze with volcanic activity. Europa, whose hidden ocean tantalizes us with the promise of life. Ganymede, the largest moon in the solar system, even surpassing Mercury in size. And Callisto, a heavily cratered world preserving the ancient history of impacts. Finally, Jupiter's immense magnetosphere and powerful radiation belts act as a cosmic shield, deflecting incoming asteroids and charged particles and protecting the inner planets. In every sense, this mighty gas giant is not only a breathtaking marvel, but also the silent guardian of our solar system family. Saturn, the queen, with graceful rings. Saturn, the sixth planet from the Sun, reigns at an average distance of 1.43 billion kilometers. Though merely one member of our modest Milky Way, this queen boasts a beauty unmatched. Its spectacular ring system stretches from some 70 kilometers to over 80 kilometers above the cloud tops, composed of trillions of icy and rocky particles that shimmer under sunlight. A single day on Saturn lasts just 10 hours 33 minutes, causing the planet to bulge markedly at its equator and flatten at its poles, while a full orbit of the Sun takes 29.5 Earth years. With a mass 95 times that of Earth but an average density of only 0.69 g cm/cube, Saturn could literally float on a hypothetical ocean. Saturn's family includes more than 150 moons, the most famous being Titanthe, only moon with a dense atmosphere, liquid lakes, and methane-rained Enceladus, whose jets of ammonia-rich water spray hint at a subsurface ocean. Dozens of smaller moons complete this dazzling entourage, each awaiting future exploration. The 13-year Cassini-Huygens mission unveiled the intricate structure of Saturn's rings, from the bright A and B rings to the fainter C and D ring highlighting features like the Cassini division, a gap carved by gravitational interactions with its moons. Saturn is not only a masterpiece of nature, but also serves as a cosmic gatekeeper, shepherding asteroids and comets and protecting the inner solar system family from the relentless bombardment of space debris. Uranus, the hermit, tilted on its side with endless seasons. Uranus stands alone in seventh place, orbiting the Sun at roughly 2.87 billion kilometers, with a year lasting 84 Earth years. Its most striking feature is its 98 degrees axial tilt, almost lying on its side, so that one hemisphere basks in continuous sunlight for 42 years, before flipping into 42 years of darkness, creating seasons nearly 16, 0 times longer than those on Earth. Composed mainly of hydrogen and helium mixed with methane, Uranus wears a gentle, sea-green hue. The highest cloud top temperatures plunge to about 214 degrees Celsius, making it the coldest of the gas giants, despite lying closer to the Sun than Neptune. A single Uranian day lasts just 17 hours, 14 minutes, spinning the planet into a pronounced equatorial bulge that gives it a donut-like profile. Uranus's faint ring system dozens of narrow, dark bands of ice, and dust extends only a few thousand kilometers above the clouds, scattering almost no sunlight. At least 27 moons orbit this tilted world. Among them, Miranda's patchwork terrain of cliffs and canyons and Ariel's chaotic surface hint at a violent history of collisions. This solitary hermit planet, with its tranquil atmosphere and seasons that span lifetimes, still guards many secrets about its internal heat source and deep structure. Future missions, perhaps inspired by Voyager's legacy, promise to open a new chapter in our understanding of this enigmatic ice giant. Neptune, the distant giant. Neptune is the 8th planet from the Sun, orbiting at about 30 astronomical units, 4.5 billion kilometers. A full revolution around the Sun takes 165 Earth years, while one Neptune day lasts just 16 hours. Composed primarily of hydrogen and helium with a hint of methane that gives it its deep azure color, Neptune's upper cloud decks average a frigid 220 degrees Celsius, though temperatures climb beneath the stormy layers toward its core. This ice giant is famed for its colossal storms. Transient great dark spots akin to Jupiter's Great Red Spot have appeared and vanished, their furious winds reaching up to 200 kilometers, each the fastest measured in the solar system. Neptune's tenuous ring, System 5 faint bands of ice particles, and dust extends only a few thousand kilometers above the cloud tops, barely catching the Sun's light. Neptune's retinue of moons also intrigues scientists. Of the 14 confirmed satellites, Triton stands out as the only large moon with a retrograde orbit, spewing nitrogen geysers that hint at a hidden subsurface ocean beneath its icy crust. Voyager 2's flyby in 1989 provided our first close-up images and invaluable data, but no mission has returned since. Future proposals to explore Neptune in greater depth promise to unveil the remaining mysteries of this remote, majestic world. Mysterious objects in the hypothetical 9th planet. Beyond the distant edge of the solar system, past the Kuiper Belt with its thousands of icy bodies like Pluto, Eris, and Sedna, lie secrets still waiting to be uncovered. Since 2016, astronomers have noticed a peculiar clustering of orbits among a group of extreme trans-Neptunian objects, ETNOs. All tilted and aligned in the same direction, hints of an unseen giant tugging at them, the so-called Planet 9. Caltech simulations suggest that this ninth planet could weigh 5 to 10 times Earth's mass and orbit between 400 and 800 astronomical units, 6,120 billion kilometers, from the Sun. At that distance, our star would appear as a faint point of light, leaving Planet 9's frozen surface at roughly 220 degrees Celsius or colder. Although it has never been observed directly, the orbital dynamics of Sedna, 2012 VP113, and many other ETNOs imply the strong gravitational influence of a large, hidden planet. Astronomers hope that next-generation observatories like the Vera C. Rubin Observatory, LSST, and the Gaia spacecraft will detect the faint glow of Planet 9 if it truly exists. Whether this hypothesis is confirmed or refuted will not only clarify the architecture of our solar system, but also open a new chapter in our understanding of how distant planets form and migrate. Are we on the verge of meeting the solar system's final, enigmatic member? Keep exploring with Astronomy Universe so you don't miss a single cosmic clue. The journey through our solar system, from the giant beacon of the Sun to the fiery rocky worlds, the ringed and storm-racked gas giants, and even the mysterious Planet 9 at the distant frontier paints a picture of a diverse and wondrous cosmos. Each body bears its own story, testifying to 4.6 billion years of formation and ceaseless motion. The more we learn about these celestial neighbors, the more we cherish Earth, our only known home of life, and the more we feel the responsibility to protect it. If you enjoyed this cosmic adventure, don't forget to like this video to show your support. Comment below and tell us which planet impressed you the most. Subscribe to the Astronomy Universe channel and hit the bell so you never miss our next spacefaring discoveries. See you in the next video, where we'll unveil even more mysteries beyond the solar system and reach for new horizons.